So today we are going to learn about the next type of function. We have learned about lines, which is the linear, which means that the highest exponent is 1, and it looks like a line. You have learned about exponentials, when the exponent is a variable, and it looks like a J-shaped curve, if you remember that. So it's like that J-shaped curve that has the asymptote and everything. Yeah. Also known as cinnamon, right? So the next type of function is called a quadratic. A quadratic function is going to be a U-shape. A U-shaped curve that has a highest exponent. The highest exponent must be 2. You know it's quadratic if you see that highest exponent being 2. And we can go from there. And we are going to create this U-shape. Some of you guys saw the word parabola on the board.
Parabola.
It's parabola. That is the name of a quadratic function shape. It creates a parabola. A linear creates a line. An exponential creates a curve. And a quadratic creates a parabola. So please do not describe this as a line. It is a parabola. It's not even a line. It has a curve to it, so it can't be a line.
Is that an alien species?
It's not straight.
All right. So, what is a projectile or a quadratic function? Please focus. A quadratic function is a curve called a parabola that may open upwards or downwards and vary in width or steepness. All parabolas are symmetric through the line of symmetry which goes through the vertex. So let's talk about what each of these are. So this is 3 examples of some parabolas here. So we have a parabola here. We'll call that f of x. We have another parabola here. Please stop, guys. And we'll call this one g of x. And we have a third one here, which we are going to call h of x. Those are all parabolas. That U shape is a parabola. It has something called a vertex on it. The point, the lowest or highest point is called the vertex. So these little points here that I'm putting in, that is known as the vertex. Through the vertex is something called the line of symmetry, which is always a horizontal line. Not a horizontal, sorry, vertical line. So it's a y equals equation, and that is known as your line of symmetry. Why is it called a line of symmetry? Why do you guys think that? It is symmetrical. Why is it symmetrical? What do you notice about that, Connor? Yeah, if you were to fold it along this line, these 2 purple lines, or purple curves, would line up with each other. It's symmetrical. So you'll notice that these all have a line of symmetry through the vertex. So this one has a line of symmetry through 1, 2, 3, 4, 5, 6, x equals -6. This one is x equals 1. And this one is x equals 4. So these all have lines of symmetry, which, as Connor has said, they're the same on both sides of that line. So if you're looking at a table, you can figure out where the vertex is. Who can tell me where they think the vertex is in that table that is to the left there? Why do you think it's at 0, 0? It just happens to be the middle number. But why, mathematically, would that be the vertex? What do you guys notice is happening? Remember, symmetrical, meaning it's doing the same thing. Yeah, Connor?
I have a question.
Yeah.
On the middle line, why did you put x equals 1?
Because it's going through 1.
Oh, okay. I thought so.
Why do you guys think, he's right that it's 0, 0, but why is that 0, 0? What do you notice is happening, Riley?
It's directly split down the middle. It would be on a graph.
Yeah, if you look at this, what is repeating? Our y values. Do you see our y values are repeating, which is creating a symmetry there? So the symmetry is always around the vertex. So the symmetry is always around that vertex. So you can see that symmetry. Do you guys see the repetition that's happening on the y there? So that is how you would find a vertex in a table. Okay, what question do you guys have there? Okay, if there are no questions, move on to the next slide.
Moving on to the next slide.
It's a lot of definitions today
Oh, jeez.
because it's a new unit and you don't know what a quadratic is. So, all right, so this next thing here says a minimum point on a quadratic function is the lowest point on the graph of the quadratic function. It is always going to be the vertex when it is opening up. So you find the vertex when the parabola is opening up. So if you look at this second one here, do you see how your parabola is opening upwards? Right? This is a minimum because it is the lowest point at our vertex there. And that looks like it's at 0, -8. So we have a minimum point at our vertex of 0, -8. Thank you, Jeff. So a maximum is a point on the quadratic function. It is the highest point on the graph of the quadratic function. It is a vertex when the parabola opens down. You just said it very well that time. So you'll notice that this first graph here is opening downwards, and that vertex point is the highest point, which is why it makes it a maximum, which is at 0, 16. So the vertex of a quadratic function is either the highest or the lowest point. If the graph is opening up, it is a minimum. If the graph is opening down, it is a maximum. So those are some of the things that we just learned with that vocabulary. Questions on what a maximum or a minimum is? Or what the vertex is, because if you don't know what the vertex is, you're kind of in trouble. Yes?
Kind of off topic, but have you ever had someone who graduated with 100%?
Who what?
Graduated the class with 100%?
Like, pass this class? No. It's hard to get 100% in math classes.
You have to get like...
Because I really don't give extra credit either, so...
1 point.
What are my solutions? Solutions are any ordered pair that is on the curve that make the quadratic equation true. So a solution is anything that would make this equation of this quadratic true, meaning it lies along the parabola. So looking at the following graph, are the following points solutions to the quadratic function? So Brian, -1, 0. Is -1, 0 a point along our parabola? Yes. It is on our curve, our parabola. This is -1, 0. So it is a solution. So again, it is not a line, guys, so be careful. It is a curve or a parabola. You could say solution, that's 2. That's fine. Cassie, how about 2, 3? Is that a solution? 2, 3 is up here, and that is it on our parabola, on our curve, so this is a solution. Mike, how about -1, -1? No, -1, -1 is down here. So that is not a solution to our curve because it is not along our curve. Emma, can you tell me what the ordered pair for my vertex is?
0, -1.
Good. That is where my symmetry is happening here. It's at 0, -1. It is a the point where those two sides come together and meet so that they are symmetrical. Jordan Fields, is this a max or a min? It is the lowest point, right? It is opening up. So it is a minimum, we can say for two reasons here. It is the lowest point. And the graph opens up. What is the equation for the line of symmetry here, Kaylee? What is the equation for the line of symmetry? What do you notice about all of our equations of the line of symmetry on that first slide I did with you? What are they always?
The same number.
What do you mean by the same number? They were different. No, I wrote the equation for all the lines of symmetry here. Did you write them down? Yes. What did you notice they all are?
Just kidding, no they're not. They're only one number.
They're one number and they're always what? Y or X?
X.
So we know our line of symmetry is a vertical line, so it needs to be a x equals the equation, and it goes through the vertex, so what does x equal?
-1.
Not -1. What's your x coordinate of the vertex? 0. So x equals 0 because it is the x coordinate of the vertex. All right, questions on that stuff before we get into some of these examples on the next couple pages here? Now that we know what some of these words mean a little bit better. All right, so an object is launched directly upwards at 64 feet per second from a platform 80 feet high. The equation for this object, where s is the height and t is the time, is s of t equals -16t squared plus 64t plus 80. What will this object's maximum height be, and when will it reach that height? So one thing that you guys need to realize here is we know this is a quadratic because the highest exponent is 2. So you know it's quadratic because the highest exponent is 2.
Wouldn't it be 144?
What?
Okay.
144?
Wait, what?
I'm talking about why it's quadratic. I haven't answered any questions yet. So you know this isn't a line
I don't.
because we have an exponent higher than 1. Remember, linear has an exponent linear means the exponent is 1. But we have an exponent higher than 1. We have an exponent of 2, which makes it quadratic. We know it's not exponential because we know our variable is not our exponent. So we need to be able to separate those things so that we know which function we are dealing with. So this is a quadratic, which means it's going to create that parabola, that U shape. So what will the object's maximum height be, and when will it reach that height? So Mike, you kind of started answering it. What is the maximum height of the object? So let's first label this. So t is your time, which is your x-axis, and it's time in seconds. Good.
You start at -1.
No, it starts here. This stuff doesn't make sense. We'll talk about that. And this is the height in feet. So, Mike, what is our maximum height, and when will it reach that height?
2 seconds it will reach 144.
So our highest point is 2,44, which means at 2 seconds, the object will be 144 feet. Very good. So the maximum height is up here at the vertex. So Justin Powers, at what time is the object 80 feet? Okay, but there's another one. At the start, what else is at 80 feet? Also at 4 seconds. So you'll notice that this object starts at 80 feet and it comes back to 80 feet after 4 seconds. This object is being thrown up into the air and creates an arc and comes back down. So if I had enough room in here, I could throw something up and you know that it would come back down, right? What goes up must come down.
But it says it went directly upward.
It still goes down.
Yeah, I know, but why is it
So
an arc?
so that's a really good question. So why is it an arc? This is the graph. This is the time that it spends in the air. So it's not actually showing like what it's doing in distance-wise. It's showing its time. So it goes up and down over 5 seconds. Do you see that? So it still could be, seriously, I could throw something up in the air and it could land right where it came down, but it still took time to do that, right? So it spreads it out over the time. Does that make sense?
Yeah, I still don't get the negative one thing.
Okay, so let's talk about that now. Even though I wasn't going to get to that yet, but he's asking why is -1 on the graph. Could we even talk about this time here? No, negative time does not make sense. So really, the graph that we're looking at is only in the positive quadrant. You would not even look at this part of the graph. This would be crossed off because negative time does not make sense. It starts here.
Is it negative?
It actually starts at 80. It's just continuing this parabola because remember, parabolas are symmetrical. It's on a building. Guys, there's way too much side conversation going on here. These are all very good questions. So it starts at a platform 80 feet tall. I could have just given you the graph right here, right? But parabolas are symmetrical, so it would continue down if it hadn't started there. But this doesn't make sense in this graph, so we wouldn't even look at it. So you just need to understand negative time does not make sense. Okay. So we have 2 times that Justin gave us. It's at 0, 80 and 4, 80. So the object starts at 80 feet. And after 4 seconds, the object is back at 80 feet. Well, then you wouldn't have thrown it in the air, and it would have been just a 0-second thing.
We have to write all this out.
We do directly upward.
Yeah, maybe there's wind.
Maybe it's a trick question.
Maybe there is no answer.
Maybe we're all.
Okay, guys, please stop. Okay, so there's 2 answers there, and you have to be able to interpret what they mean. So it says at 5 seconds, how high is the object, and contextually, what does this value mean? So, Riley.
It's at 0, and that means that it's at ground level.
Right. So after 5 seconds, the object has hit the ground.
How do you know it's at that? How do you know it's there at 5 seconds?
So it says at 5 seconds. 5 seconds. So unless we are talking about below sea level, which we can talk about, our ground is going to be at 0, right? Or above, like, elevation. But the only time height can be negative is if you're talking about, like, below sea level. Or, I guess, if you've dug a trench into the ground, then I guess that goes below the ground, too.
Maybe it's where those cool underground.
Does this graph have a maximum or minimum, and state that value and explain its meaning and context? Connor.
It's the maximum.
It is a maximum, and the maximum is at the vertex. So what is our vertex, Connor?
2, 144.
And what does 2, 144 mean in context with this problem?
At 2 seconds, it's at 144.
At 2 seconds, the object is 144 feet.
What? I wrote at 2 feet, the object is at 2 feet.
Yeah, you might want to change that. All right. What question do you guys have there? What question do you guys have on that one?
What if we measure it?
All right, next one.
Wait,
Sorry, what?
this is another off-topic question, but what do you mean people mean when they say like T minus 10 seconds?
Like count down 10 seconds.
Time minus.
It's just like if you're counting down.
So I can say T minus 10 seconds.
It's like when rockets launch.
Yeah, I know, that's right.
Okay, an object is launched at 19.6 meters per second from a 58.8 meter tall platform. The equation is for the object's height, s, at time t after launch is s of t equals negative 4.9 t squared plus 19.6 t plus 58.8, where s is something, where s is height in meters. That should be height. So, first thing you need to realize here, there's a few things you need to realize here before we do anything. Mike, just 1 second. You'll see that our highest exponent is 2, which is why this is a parabola. It is not 1, which would make it linear. It's not the variable, which would make it exponential. The next thing you need to understand is this n value here. Do you see this 58.8? Where else do you see that in the problem? It's your starting. It is your y value here. So this number here is your y-intercept. It's your starting height. Just so you guys are aware. So we have our time in seconds still. And our height is in meters this time. Does negative make sense?
Yes.
No, negative time does not make sense. So we are not going to look at this part of the graph.
We're not going to look at that part.
So you're like,
Because you guys need to understand contextually what you should be looking at. A parabola creates the U shape that is symmetrical. I want you to understand that. But in context, you may not look at the whole parabola. Does that make sense?
Yeah.
So when does the object hit the ground then? So Tanari, when does our object hit the ground?
6 seconds.
So we are at the ground when it's 0. So at 6, 0. So after 6 seconds, the object hits the ground.
any space in between it hits the ground, so it just looks like it hits the ground. That'd be really bad.
So it says find s of t equals 74 and explain its meaning in context. So Grace, when we are at 74, which is about right here, right? How high is how many seconds have passed? 1 and? 1 and 3. What goes up must come. So oftentimes we are going to have 2 outputs. Oftentimes we will have 2 of those. For each output we'll have 2 inputs.
Sure.
Because what goes up must come down.
Well, if it goes up, it'll go up.
If it goes up, then it still continues going up forever.
No. After 1 second, the object is 74 feet. And after 3 seconds, the object is back at 74 feet.
We have to do this on our
Meters.
Yes? Oh, it is meters. You are right. We switched units. Thank you. I don't know. Okay, it says evaluate. Stop. That's not times 3. Feet and meters are 2 different. One's English and one's ours. Like, that's not even the same thing. Okay, evaluate SF4 and explain its meaning and context. Yes?
You gotta draw the stuff on the graph.
No, I'm just doing this so you see what I'm doing. So, Alyssa, what is SF4? Is that the input or the output? input. It's inside. So our x value is 4. When our x value is 4, what is our y value? And it's going to be a decimal here. What is it going to be about?
That number.
59-ish.
59.6.
So after 4 seconds, our object is about 59 meters. Colin, what is my maximum point and what is its meaning in context?
2 and then the 78.4.
And what does that mean in context?
It means that the object was at 78.4 feet in 2 seconds. Meters?
I don't know.
Why did you change possessive, like, in the first one you put the object, but in evaluate you put
I don't know. It doesn't really matter. All right. What questions do you guys have on those ones before we look at some tables?
Fart.
Okay. Please make sure you're paying attention. Shh. You and a friend are hiking in the mountains. You want to climb to a ledge that is 20 feet above you. The height of the grappling hook you throw is given by the function h of t equals negative 16t squared plus 32t plus 5. Remember, this is squared, which makes it quadratic. Our y-intercept is going to be at 5. That's our starting position. So it says find h of t equals 21 and explain its meaning in context. Is that the input or the output, Jana? It's outside, so when our output is 21, what is our input?
1.
It is 1. So what does that mean, Jana, in context? What does 1 comma 21 mean in context? So remember, t is time in second, and this is the height in feet. So you got to be careful. At 1 second, the grappling hook is 21 feet. It's the thing that you can like throw up to like rock climb with, like that they use. Okay, please stop talking. When time has not passed, how high is our hook? Jack, how high is the hook when time has not passed? 5 feet. So that's when 0 seconds, it's at 5 feet. So at 0 seconds, the hook is 5 feet. Probably because somebody's holding it in their hand like around, you know what I mean, around 5 feet. So that's why. When will the hook hit the ground?
In between 2 and 3.
So there's 2 different things you can think about this. Yes. In between 2 and 3. And how do you know that?
It's 5 and then it goes
Seconds, because it switches from positive to negative. 0 is somewhere between these 2 numbers. It's somewhere between 5 and negative 43. Yes. You don't. But it needed to be on here so that you guys knew when the hook would come back down.
Oh no, not the hook.
So you know 0 some here and here. And so this goes on to what Kaylee said. What is the problem with some of these? First of all, negative 1 second is not possible. Right? And can you have negative height if it's not below sea level?
No.
Negative 1 second is not possible. The last of it.
I think going from 21 is 5. Negative 43.
Because it's quadratic, you're squaring things. When you square things, they get bigger. Connor.
How come on the top of the graph it's negative 43 and at the bottom of the graph it's negative 43?
Good question. Why is it negative 43 here and negative 43 here? What do we know about a parabola?
It goes up and then comes back.
It repeats. It's symmetrical. So where's our vertex in this problem then if it's symmetrical? 1, comma 21. Do you guys see the symmetry here?
Oh.
So Connor, it has to repeat to be a parabola, okay?
Oh. Yeah, that's kind of confused. I was thinking about like the parts of the problem, like how can it.
That part what doesn't make sense though. It's not possible.
Yeah, I know. That's how I confused.
Okay. We are going to just skip to this last piece here. How many inputs are there for every output?
1. 2.
Typically 2. Because what comes up goes up?
Must come down.
Must not go.
Other end said yes when it's at the peak.
What do we call that peak?
Vertex.
The vertex. So there's only 1 at the vertex.
Always gotta take stuff.
He's the one that said it.
Riley, those applications.
How many outputs are there for every input? 1. These are like, you're just going to hit it once. So only 1. All right, guys.
They are.